brought to you. Today's presenter is Lucidworks Senior Engineer and Lucene Solar Committer, Tim Potter. Thanks for joining us today, Tim.
Thank you, Aaliyah, and welcome everyone. So today's topic is obviously a lot of hype and news in the media about big data. So what I want to do is sort of kind of see where search fits in that big data landscape. And I promise to sort of keep the hype and the grandiose statements to a minimum today. And really just want to focus in on actionable items and sort of concepts that I see when I actually work with some of our customers. So after kind of painting a picture of where it fits in the data landscape, I'd like to touch on a few of the concepts that I think are on a lot of people's minds and come up in engagements, and such as running Solr on HDFS, various indexing strategies, security. And then I also want to talk a little bit about this, sort of where search might fit into the Lambda architecture. If you're not familiar with that, it's an architecture popularized by Nathan Mars, who previously worked at Twitter and wrote Storm. And I think it has some interesting ideas of actually how to deal with some of the complexity in big data systems. And then finally, I'll probably wrap up with a little bit of discussion about Spark. It's very exciting and probably one of the more popular big data frameworks out there. And then also kind of see how we use it in Fusion. So I probably don't have to say this, but I think it's worth pointing out that Solr really is the standard for enterprise search. And if you look at just the small sample of the logos I put on this slide, you'll see that these are actually very large organizations that are using Solr for mission-critical applications, right? So Solr is on the front line of revenue-generating, user-facing applications for these large organizations. And it probably also goes without saying that every one of these also has big data and needs to sort of fit search into their big data strategy. So why are we here today? Why do we care about search for big data? And I think probably the most obvious, but even sometimes often overlooked, is that actually search engines are incredibly fast. Speed at scale is really the phrase that sticks in my mind when we're talking about search. And of course, there's a lot of work and effort going into Hadoop and SQL on Hadoop and those type of things, and Spark and in-memory processing. But at the end of the day, responding to complex queries very, very quickly is at the heart of what Solr can do. And so I think as we kind of paint this picture of we have more and more data, and more complex questions, the concept of speed at scale is really at the heart of all of this, and why I think search is important for big data. So the other one is actually, and I'll deviate a little bit here to tell you a little bit about my background. So before I was a Solr committer with Lucidworks, about 4 years ago, I joined a team to work on a big data architecture for the Dachas group. And we built a platform called the Social Business Index, which measured and kept track of all these key performance metrics for brands and their performance in social media. And when I joined that team, this was about 4 years ago, the big data landscape and Solr and all these were very much different than they are today. And so we built pretty much a lot of the things that I'll talk about today. We had to build from scratch, but now they're built into platforms like Fusion and work with technologies like Spark. And so I've actually built these things, and some of what I'll talk about today is kind of based on that experience. So getting back to, again, why we are here and why search is important for big data. Another one I think is important is actually from the search engine. Solr doesn't just respond to keywords and give you a rank list of basic document matching, obviously. One of the more powerful things in Solr, and one of the things that got people excited early on when using Solr, was this idea of facets. And now we have pivot facets where you can actually go down levels deep and pivot off. You can basically hang stats off of facets. And all of these are sort of what I call basic, analytics, but they're still very, very powerful, right? And the key here, again, is you can get facets and stats off facets to drive basic visualizations over massive amounts of data. I've seen banana dashboards put together by our field engineers that query over billions of documents in seconds and give basic visualizations around that. So again, that's a very powerful aspect of search. Another one, I think, and this is one that I find very interesting, is this idea that big data is sort of inherently lends itself to ad hoc exploration. If we knew all the questions we wanted to ask of our big data ahead of time, then really tools, the business intelligence tools and the existing data warehousing tools that are very good at creating aggregations off of structured data and answering queries we know we want to ask of the data, those exist and are very powerful, and we wouldn't probably have all this hype around big data. So I think really the idea of querying structured as well as unstructured data in a very exploratory and discovery type way is really inherent into what people are doing with big data today. Another one that I think is actually also interesting for me is the fact that people pretty much grok search these days, right? And what I mean by that is we use search on almost every site we go to, and nobody thinks, they don't have to be explained search. Search is a very natural thing, entering some natural language queries and getting back relevant documents. So people really understand that, and taking that into the big data space makes a lot of sense because you don't have to craft very complex SQL queries to immediately start getting back interesting aspects about your big data. And then another one, and we actually did this at the Dotgist group with our social media analytics platform, was providing context behind the aggregation. So I'm showing you a pie chart. Well, let me dig into an interesting number I see on that pie chart and look at the raw data and see what's going on behind the scenes. And doing that, pulling that out of an HDFS directory is nearly impossible to do it in a time where a human would be acceptable. But from a search engine, that's what they do, and it's very, very easy to do that with search. Okay, so I'll probably refer back to this, but I kind of wanted to call out a common use case that we see, and I've actually given a webinar previously on this, so I won't spend that much time digging into the details. But a common use case that I see more and more of around big data and applying search in big data is this sort of log analytics over time ordered data. So it doesn't necessarily have to be logs generated from a machine. It could be logs of activity of users using actually your search engine. And built into Fusion, we have this idea of basically taking all of that exhaust that comes from your users interacting with your search engine and your content and using it to drive recommendations, improve relevance and boosting and those type of things. So this idea of over time, we're capturing this time-ordered data, right, be it events or what have you. Well, that needs to be stored because at scale, right, oftentimes, especially for the large organizations that I put on the screen previously, the raw data is just in such vast volumes and velocity coming into the system that it has to be stored in HDFS. And this is where we start to see this idea of big data and search overlapping. So now it's in HDFS. It's literally not useful to anybody. You can't do analytics by just looking at an HDFS directory. So now you need to basically decide, well, how are we going to access that data? And that's where the idea of indexing into Solr and Fusion come into play. But now when you talk accessing and indexing into Solr, you have to decide, well, how much data to index and how fast, or rather, how soon after a log event occurs do people need to basically be able to query it and make sense of it and have aggregations off of it. So there's questions like that. And one of the things that kind of sticks with me here about this log analytics and just big data search in general is that I've seen if we take a step back for a second, when you did business intelligence and data warehousing, there was a lot of this kind of pre-planning of what questions we want to ask of the data. And with search, that gets relaxed a bit, right? Because again, there's this ad hoc nature of unstructured text that, of course, we do some text analysis on and those sort of things. But there's still always that ad hoc feature. But when you're talking about really large scale, one of the things that sort of sticks with me is that there's really no free lunch at large scale, and you have to do things like proper schema design. And I've seen this time and again where, even a field that we're wanting to do range queries off of very efficiently was not indexed correctly to do efficient range queries at the Lucene level, or the idea of using doc values for fields you want to sort on and compute facets on. So these are things that I think as you start to approach the question of searching big data, the idea of really doing some upfront schema design and planning is extremely important. This is basically a layout of a time-based partitioning scheme that you can do in Fusion today that allows you to essentially partition your data by time, which allows you to very efficiently execute queries that have that time range aspect to them. More recent data you want hot and to respond very quickly, to drive real time or near real time dashboards and things like that. But then you also want to do some historical data analysis and things like that. So this is a type of partitioning scheme. And so it goes back to, again, as you're planning for search and big data, these are the type of things you have to think about. No longer is it you just send a bunch of big data into Solr and it figures it out. So now I'm going to kind of dig into some of the things that crop up when I work with customers and that I see when I work in the Solr community. And the first is really this idea of running Solr on HDFS. And it's been in the works for some time. It's really been most of the people that work on the search team at Cloudera are doing a lot of good work in this area. And I'd say it's actually really maturing, but there's still some issues. So recently, I have a toolkit called the Solr Scale Toolkit. It's open source if you're interested in checking it out. It has the ability to essentially spin up Hadoop clusters and bring up Solr clusters and do indexing performance. And my test actually, compared to just local SSD, my test showed that indexing into HDFS on the same exact hardware, same EC2 nodes, was 23 to 25% slower, depending on the type of replication I used and those sorts of things. So that's a pretty significant hit when you're talking about just raw indexing performance. But they're beyond performance. There are interesting things about running Solr on HDFS, and one really is this idea that IT organizations are seeking to sort of bring more of their critical data apps, and I would assert that Solr and Fusion are definitely that, especially for the organizations I showed on the first slide there. Bringing that under sort of the one cluster that can be managed. There's the technology called Yarn that allows you to do that, and Solr runs on Yarn. So really, beyond performance, you definitely can get better return on investment if you've gone out and invested in a large HDFS cluster and trained up staff and built essentially the IT organization around that. It makes a lot of sense to put a mission-critical app like Solr on that platform, right? So that gives you a lot of operational efficiency. And then there's also the question of security, which I'll talk about in a few slides. But the point there is that if your app can basically deal with the lower raw indexing speed, and there's ways to mitigate that by having more shards and more nodes, then this is something you can probably consider. And if you do want to run Solr on Yarn, you actually need this because if a Yarn container goes away, Solr needs to come back, and it's not guaranteed to come back on the same host that it was, and so it'll need access to this distributed file system. Solr on HDFS also enables this concept of auto add replicas, and I'll talk about that. And I also want to mention that there's some interesting features that I think make Solr on HDFS a lot more compelling. And one is this idea of basically using Zookeeper as a lock. And that's really to work around some sort of deficiencies in using HDFS for locking, like basically Lucene needs a file system lock on the index directory. And then also there's this idea in Solr 6237, which is allowing replicas to share an index. Let me basically give a picture of Solr on HDFS, and that'll highlight some of the issues that crop up. So basically what I have here is a single shard with two replicas, right? And effectively they're using HDFS as their store for the indexes, okay? And so at the Solr level, there is Solr replication between these two, just as you would if you were using the local file system, right? And Solr, when it indexes, basically writes into HDFS. It's advised to go around the block cache for that and just go directly to HDFS. But read should go through a thing called the block cache, which is really intended to kind of substitute for the OS file system cache, right? So that you can load some of these blocks off of HDFS into local memory to improve read performance. But the kicker here is that in addition to the Solr replication, HDFS is actually replicating the blocks itself out to other HDFS nodes, right? And that's just how HDFS works. Of course, you could set up to have single replication for these files in HDFS, but that's really not recommended because it just at the end of the day is HDFS administrators don't want to have a different policy for different directories and those types of things. And so this is the scene, and the biggest issue here is that you're paying for double the disk space, right? And at very large scale, again, getting back to our main topic here, big data, double the disk space, really for no actual benefit to the organization is a costly thing, right? So let's talk about auto add replica, which kind of changes this scene. The idea is that basically instead of using and having Solr replication, we'll just go ahead and get rid of that. Okay? And so now we only have a single replica per shard. And in the Solr cloud architecture, there's a role called the overseer, which uses Zookeeper to basically know when shards are up and replicas go up and down and those sorts of things, right? And again, we have our data, which is replicated out on some other HDFS node. So now let's imagine that goes away. And so now what happens is that shard 1 is now offline, right? There's basically that data is not accessible to serve queries and serve updates. So essentially what happens is the overseer with this auto add replica setting, which is built into Solr, notices that went away and can basically bring up another replica on a healthy node in the cluster. And since the data is in HDFS, that didn't go away when the node crashed, at least not all copies, because we have HDFS replication, that you can basically bring up a new replica and keep your Solr online. Now, it's not instant, obviously, but it can be a mitigation strategy if you don't want to actually pay for the double disk and you're willing to deal with maybe a second outage or so. That's auto add replica. Okay, so now let's go ahead and turn our attention to, so now we kind of understand Solr on HDFS. Let's turn our attention to various indexing strategies because this comes up a lot. For the most part, there are many tools available. And I'd say the Solr community and Lucidworks, as well as like Cloudera and Hortonworks, have really done a lot of work to make sure Solr and Fusion are really first-class citizens in the Hadoop ecosystem. So this means that out of the box with Solr, there's a contrib module that you can basically build indexes in MapReduce jobs and then merge them into a final index, very similar to kind of the original thinking that Doug Cutting had when he wrote Hadoop of building indexes out in MapReduce and then merging them together to do web scale search. So that's built into Solr Contrib. And I actually think it's a pretty interesting tool for doing very large re-indexing jobs. Lucidworks, we produce this Lucidworks output format, which is essentially Hadoop speak for basically being able to configure a MapReduce job to send its output to Solr. And you can do that, from mappers or reducers and things like that, and handles all the details of writing out to Solr. We also provide a serializer, deserializer for Hive, a pig store function, as well as ways to index from HBase into Solr. There are also ways to, if you're working more of a near real-time, like streaming paradigm, such as Storm or Spark Streaming, we at Lucidworks have put out a couple of different open source projects on GitHub for that type of thing. So now everything up there on the top really is kind of open source toolkits, tools that your development team can put together some sort of indexing strategy, right? And again, as I mentioned, 4 years ago, we had to build all of this infrastructure at Dotch's Group, and I actually wrote a pig store function for Solr and this type of thing. And while it's doable, it's really not necessary. One of the things at Lucidworks that we believe is that big data doesn't have to be hard, right? And so we come out of the box with, I don't even know the number, but hundreds of potential connectors, right? And a lot of them that are really built in for working directly with Hadoop and HDFS, right? So we partner with the major Hadoop vendors to have connectors that can basically go in and pull data out of HDFS or Hive or what have you and index it into Solr. So these are no coding. These are basically you configure them, point them, give them the basic permissions, security access, what have you, and then they do their thing. So not much to say about that other than it really makes working with big data so much easier when you can just point a connector at it. So let's take a look at one of our solutions. This is actually in being used today by some of the customers I've worked with. And the idea here is that we want to build up a large Solr index. And we can go back to my use case of log analytics or whatever. And we're gonna basically take data out of HDFS, do various enrichments, ETL pipeline type stuff on it, and then send it into Solr. Okay, and so in Fusion we provide what's called pipelines, indexing pipelines, right? And pipelines we provide out of the box, I think, 30 plus index stages. Okay, and these are things that again you don't have to code. You just nice drag and drop interface to allow you to wire together a pipeline of ETL actions to enrich your documents as they flow through the system, right? And this could be you can write a little bit of a JavaScript. You can use Tika to do some low-level parsing. Maybe you're indexing PDF documents. You can do natural language processing, regular expressions, JDBC lookup, all the kind of ETL data enrichment type things you can think of are really built into this. But what happens actually, again, in thinking in the big data world, right, indexing usually has to be done very, very quickly, tens of thousands of documents per second, right, especially for logs applications. I've worked with customers that need millions per second, and more common is probably tens to hundreds of thousands of documents per second, right? And so if you're doing some very, very heavyweight computation in your Fusion pipeline, what we allow you to do is actually embed that pipeline in a MapReduce job. So now you're relying on Hadoop and you're leveraging that investment in Hadoop to essentially embed the pipeline in mapper tasks, or it can be reducers if need be. To do all that work, that parallelizes very nicely across the cluster and then indexes into Solr. And again, you'll get one map task per block on your input side. And that input side, we support all the common Hadoop formats, CSV, sequence files, XML, etc. So this allows you to really scale up your indexing process without writing any code, right? This is all built in to the platform for you. You really just configure it and point it at Solr, and you're done. Okay, so beyond indexing and running Hadoop on HDFS, another one that comes up a lot that I see is this kind of question about security. And I'm by no means a security or a Hadoop security expert. And so what I really want to do is just kind of emphasize really how much work and how much Solr, Fusion, and Hadoop has come in probably the last year. So most recently, Solr is shipped with built-in ability to be Kerberized, right? And you can Kerberize Zookeeper. You can now Kerberize Solr for authentication. Obviously, that's been built into Hadoop and HDFS for a long time. And so now you really start to see this end-to-end security around your Hadoop solution. And that fits perfectly with, again, the idea that customers are starting to use Hadoop and Solr in this big data architecture for mission-critical data. And so security is probably the first thing that comes up. And again, I can't go through all the details. We could probably have a whole webinar about that. Bottom line is the community and Lucidworks and the Hadoop vendors have really been working closely together to make sure that security is basically bulletproof with Hadoop and Solr working in there. Also building in the SSL support and things like that. Taking it a little step further also, Fusion adds additional access control so that you can do document level security and those type of things once you have authentication worked out, probably through Kerberos, and you have basically you're securing the wire with SSL. There's still the idea of who can see what in this index. And Fusion makes that very easy to essentially wire in. Maybe it's LDAP groups can see which documents and things like that. And so Fusion makes that, again, a very declarative process, easy to manage. And so that's, something to look at if you're interested in document level security. And then lastly, one of the Apache open source projects out there that are really kind of taking on this centralizing administration, auditing, and monitoring for Hadoop is Apache Ranger. So I encourage you to actually take a look at that. Okay, so talk security. We've taught Solr on HDFS, some indexing strategies. Probably the next one that comes up in most people's mind, and this slide's probably a little bit of a letdown, and I apologize for that, but it's because there really is no formula I can give you where you plug in some numbers and out pops the magic number of how many nodes you need and how many documents you can land on each shard and that sort of thing. But there are really there are guidelines, right? And so Worksheet might even be a little bit of a stretch for this slide. But the idea is that you as an organization, as you're planning your big data search strategy, need to sit down and just do some hard thinking, right? And the first is to kind of think about number of documents. And if we think back to my log analysis where I was using time-oriented data and I was using a time-based partitioning scheme, well, that, first is how many documents am I going to have in an hour, right? And if it's billions, then that's going to change kind of maybe how I do my sharding. If it's, a couple million a day, then I could probably get away with a day-based shard. And so, really figuring out what is the number of documents I need to satisfy business requirements is like one of the first things to really nail down, right? And sometimes that's not as easy. The next one is really look at average doc size. If your documents vary widely, then, maybe that's not as useful. But part of figuring out what your average doc size is really nailing down the number of fields and the data you actually have to store in the index, search on, and that sort of thing. Again, going back, I mentioned the idea of doing schema design up front and really thinking through what things do I need to sort and facet on. And that's going to determine, which fields turn on doc values, and what have you. So nail down that first line, and then you can start to dig in to some of these other ones. One that I'll basically, always ask is, how many updates per second are you pushing in? And by updates, that can also just be that Solr speak for, that can be a new document or an update to an existing document or even delete. So it sort of changes to the index per second. Again, I see typically, tens of thousands to hundreds of thousands as more common in most organizations, and Solr scales fine to deal with those levels. But you have to then ask yourself, well, what soft commit frequency do we really need to have? And then soft commit frequency, if you're not familiar with it in Solr, is how frequently the searchers that basically can find documents, can see documents, how frequently do they have to refresh themselves to pull in new data, right? Is it every 3 seconds, or is a minute good enough? And again, that gets back to, for your big data strategy, is visibility of the docs in the last minute. Is that good enough? That should be, the soft commit frequency should be as high as possible, because when you do a soft commit, you have to flush caches, right? You have to basically invalidate all the data in the caches. That puts pressure on GC. That basically means queries can't be as fast as they were because their cache data potentially went away. So that can affect percentiles and things like that. I've already talked a little bit about the storage type. Again, HDFS is slower, but there are operational reasons why you might want to use HDFS still, but at least now you know it's about 25% slower, based on some reasonable tests that I've done. Maybe you can tune it and get it down to 20% slower, but bottom line is it's slower, and maybe you don't need local SSDs for your business. Again, I've talked sharding scheme. Another one that I think is interesting is picking sort of your peak QPS that you expect. Again, if we're doing analytics type applications, QPS aren't the same as an e-commerce solution, so that doesn't typically fit into this, but you also might want to look at and pick a percentile. I said 95th, maybe the 97th is what matters to you. I don't know that, so you'll have to decide. But the idea here is that you have to, when you're calculating cluster sizing, you want to know essentially what is an acceptable response time, right? And where that fits into is query complexity. So if your queries just have crazy sort criteria with faceting and pivot facets and all the awesome things you can do with Solr, well, that's going to impact some of your decision making. You're probably going to want smaller shards and a little bit more, more shards across the cluster so you can distribute out some of that expensive computation. But really the most important thing I kind of want to stress is that, no consultant can come on site and basically give you this magic formula that says, this is how you want to size your cluster. These are things to think about. And obviously there's your hardware, and IT a lot of times imposes a hardware scheme on you. You're probably, there's bare metal versus VMs and all those kind of things. I didn't mention those here because those are kind of obvious that you would sort out. But the bigger the hardware, the better. But the bottom line is, and the organizations that kind of build this into their planning up front are so much more successful, is the idea of building a test harness, a load test harness for their data on their servers. And I just can't stress that enough as how important that is when you're working out some of these cluster sizing questions and things like that. Okay, so now I want to kind of turn and talk a little bit about sort of, as you're architecting your perfect big data platform, one of the architectures out there that I feel is kind of caught on a little bit, and maybe it was a little bit more popular in 2014, but there's a lot of good in there, even if you don't subscribe to the whole thing. If you look at the book Big Data in Action, or the website there, lambdaarchitecture.net, they'll give you some baseline. But the basic idea is that you have these layers in your architecture, and the batch layer really is responsible for looking at the whole data set, potentially doing large table scans of the whole data set to come up with very accurate aggregations and computations because it can look at the whole master data set. And one of the very cool things about that, and this is one of the things I like about Lambda architecture, is it encourages you to avoid really doing a lot of enrichment of the master data set. It's really just write it as raw as possible, append only to something like HDFS, and then you can compute sort of views on that data using really complex joins and things like that. And I'll talk a little bit about kind of how Spark fits in with that. But the idea there is that you essentially feed this serving layer with computation over the batch layer, right? And you do that with kind of big Hadoop clusters or Spark clusters and things like that. To kind of paint that into a little bit of a picture, at the Dotchess group, we essentially had big scripts that did all this ETL logic and lots of joins and lots of enrichment to come up with, basically aggregations of social media data around brands, and then push that into a Postgres data warehouse. And then, our visualization layer would query into that. Very typical data warehousey stuff in this batch and serving layer, right? That shouldn't be any surprise to anybody. The key of where I think Lambda also then is interesting is the idea that, well, the batch view computation over the master data set is by its nature always behind real time and is slow to compute because it's looking at so much data, right? And so the idea here is that there's a speed layer that works in conjunction with these to pull in data in near real time and actually compute sort of the aggregations on recent data, right? And then those will then serve queries when you need to see recent data. And when I think about this architecture, obviously I work for a search engine company, and we play a lot in the big data space. And so I want to kind of figure out, well, where does something like Fusion and Solr fit in this Lambda architecture? And for me, a couple things. First, I think it goes without saying that, Solr can really scale up. I mean, there are people I was at the Lucene Revolution in October in Austin, and the scale that some people are doing is just amazing, right? Hundreds of billions of documents. And a few years ago when I was doing this, a couple billion documents was actually impressive. But so really I think you can do computations and feed those in to Solr indexes, right? And now you have that powerful ad hoc unstructured query language and all the basically facets and analytics that you need to kind of serve out of the batch layer. And of course, it's not lost on me that you also probably want more advanced aggregations on that data than what's available with a Solr query. And I'll talk about that in another slide. But then also, and I think this is more important, is powering that speed layer. What you see, and again, I mentioned Nathan Mars sort of popularized this architecture based on a lot of work he did at Twitter. And before that, was this, and he wrote Storm essentially to power this speed layer and this idea of computing streaming aggregations of data as it streams through the system. Well, I also know another very good real-time, near real-time solution that can power, queries on recent data, and that's Solr, right? So you can imagine here in this Lambda architecture, essentially the speed layer being something like Spark or Storm streaming data into Solr then to power the queries of this real-time data. Okay, so I've talked about Spark in a previous webinar. Obviously, I'll fill a whole webinar if you really want to talk about it, but I wanted to mention it here because a couple things. First is I'm starting to see that more and more people are looking to adopt Spark. So Spark ships with basically every major Hadoop distribution. So it's not you don't have to think of Spark versus Hadoop. Spark works, treats HDFS as a first-class citizen. Spark can be deployed Yarn, which is, effectively the new way to deploy jobs in modern Hadoop. And so it's really Spark and Hadoop. So you probably already have Spark if you have a Hadoop cluster. And the bottom line is that really Spark seems to address a lot of the shortcomings while keeping a lot of the sort of desirable properties of Hadoop. So, first off, one of the things you probably saw with Hadoop is, and I even mentioned them here, right, is this, there's pig, there's hive, there's all these farm animals for doing various other extensions beyond what base MapReduce could provide. Well, Spark tries to essentially add all the capabilities you'll need to build a big data framework in one core sort of platform, right? And then it exposes it to very popular languages, Scala, Java, Python, and R, right? So you can do machine learning and you can do Spark streaming, and you can actually combine Spark streaming and machine learning to do things like streaming k-means. Spark SQL is this idea of basically doing, complex aggregations over structured data. Right? And all that sits on this Spark core. Again, runs on Hadoop, Mesos, or also has its own standalone cluster management. So for me, Spark is definitely worth looking at, especially if you're kind of you've deployed Hadoop and you have you have big data needs. You can look at Spark because it's more flexible and also more powerful and faster than traditional Hadoop and MapReduce. So it's definitely worth, if you're building out maybe your next big data app, I'd encourage you to take a look at Spark. Okay, so you sat with me this long, and I appreciate that. Now we'll just talk a little bit about kind of where Fusion and all this fits together in my mind. So Fusion were obviously built on top of Solr, and we add a lot of the things such as security, analytics, cleaner API, signal processing, all of that on top of Solr. But we also embed Spark in Fusion to do essentially all of our complex computation. So as I mentioned, when users interact with a search engine, there's this exhaust that comes off, right? So which query terms did they search for, and then which documents after that did they click on, right? Even that type of very basic search signal type stuff gets stored in Solr for us, and then we can compute various aggregations, right? Collaborative filtering is based off of other users like you, also like this. Improving boosting and relevancy, right? Everybody searches for Spark, tends to click on the document three down the page or on the second page. That's a relevancy problem. How do we boost that, and how do we actually figure that out without a business analyst or a search manager having to go and figure that out and then using some behind-the-scenes boosting technique, right? We do these things, and they're actually fairly intensive computations at scale. Again, if you don't have many people using your search engine, and this isn't really a problem, you don't have Spark, you can probably get away with it with an R script. But as you have hundreds of thousands of users hitting your search engine a day, that's a lot of exhaust. And to make sense of that data in Fusion, we utilize Spark to essentially distribute that out and scale up those computations, those expensive computations. And and they're not even exotic computations. A lot of them are really just summing, doing sessionization, right? What path did the user follow through my site in this particular session, summing that up and using those sessions to then basically make decisions in the application. Okay, and so that's how we use Spark in Fusion. And then as I mentioned already, you really, in this big data world, you shouldn't be writing code anymore to bring data in to your big data, to index it or to compute it in Spark. there are connectors for that. And so I want to stress that it's important to realize that a lot of the ETL stuff is now really declarative, and you don't have to write code for those things. Okay, so this is the wrap-up slide. Again, as part of my job, I get to work with a lot of these organizations that are doing big data, so you're not alone. We are, at Lucidworks, very focused on scaling search for big data applications and have done it for a number of successful organizations. So with that, I'll go ahead and turn it over. Looks like I finished in a good time, so I'll turn it over for questions.
Thanks, Tim. So we will now begin the Q&A portion of the session. Again, if we don't have time to get to your question today, someone from the Lucidworks team will reach out to you. The first question we have, Tim, is, what does Solr on HDFS mean? Does it mean that we maintain the index on HDFS file system and not as a separate index?
Yes, that's right. So I probably glossed over that a little quickly. So Solr on HDFS means that the indexes themselves, the actual files, like the segment files, the Solr field files, all those .f, etc. files that are part of a Lucene index are stored in a directory on HDFS. Those are then broken up into blocks if they're big files and things like that, and distributed around the HDFS file system using HDFS replication. So rather than storing those indexes on the local file system, which if that node goes away and that disk is lost, then those index files are gone, they're actually stored on the distributed file system and replicated by HDFS.
Thank you. The next question is related. It's, how soon is Solr index synced with raw data in HDFS?
How soon is Solr synced? So I'm not quite sure of the question, but if we're talking about actually Solr reading the index files off HDFS, so that is that's basically instant and transparent to Solr, that it's essentially running in HDFS, and it uses the block cache to basically load big chunks of the index into memory, right? So it's not loading it over the network and things like that. But then if the question is, if there's data in HDFS that you want to index, that's where you have to utilize one of the strategies I talked about. It could be a pig job, or it could be, using our Spark connector to index HDFS, or as I mentioned, we have tools, connectors built into Fusion that allow you to index and run your documents off HDFS through a pipeline in MapReduce and then feed into Solr. So I'm not sure which the question related to, but hopefully that helped a little bit.
Thank you. The next question. Is the Fusion index pipeline built on top of MapReduce contrib module?
That's a good question, and the answer is no. So it's built on top of the Lucidworks output format that I mentioned and SolrJ. So, we've been doing sort of Hadoop and Solr integration for many years, and so we built all of that kind of MapReduce library, and it's our own MapReduce jobs. And the difference is that the MapReduce tool that I showed you that embeds pipelines indexes in real time to Solr, right? And so you can actually achieve very high throughput and near real-time indexing, right? So your document from hitting HDFS to being written into Solr can be a very short time frame, right? With the MapReduce contrib module in Solr, that's a lot more batch-oriented because it essentially embeds Solr into each mapper, uses that Solr to build mini indexes in each mapper, a reduced task actually, and then save that out to HDFS, and then there's a merge step that says, okay, I want to merge this freshly created full index into an existing index. And so the actual time to create a document and make it, the time to index a document and make it visible to searches is a lot higher with the MapReduce contrib. And as I mentioned, the biggest use for that I see is if you have a very large-scale re-indexing job. That would be a fantastic tool to do because you can run in the background and basically merge things together once the jobs are done, and then put that index that was created on mine. But the Fusion indexer is a lot more real time, but it's still scalable because you can scale it out across your Hadoop cluster.
Great, thank you. Can you give a basic sizing rule of thumb that you use for estimating Solr clusters?
Sure. So one of the ones is just the number of documents per shard that you want to achieve, and I think it varies. There's a lot of variables that go into that, but for me, around 100 million to 250 million per shard is a good starting point. And again, I kind of want to stress that you don't know that that'll work with your data because until you've actually done some testing with your data and your queries, right, and your indexing load. But that's a one that you can start on. The other one I think is important is to realize that GC and GC pressure, so garbage collector and garbage collector pressure, are still very much a concern, and so it's actually better, a little bit better, and you can control your pauses and the length of pauses by having sort of smaller heaps, so smaller max heaps, and so that will also help you be able to drive out some of these numbers of, well, if we want to basically have like a 12 gig heap per JVM. So you can have more JVMs in the environment, and then that will drive some of the sharding sizes as well, as if you have more JVMs than if you're trying to do a huge heap that if it does actually have to go into GC will end up having a long pause that can trigger zookeeper session expirations and all these bad things you don't want to happen in Solr. So those are the kind of the two ones. Is kind of a reasonable heap size, 12 to 16 gigs, and then off of that, 100 to 250 million docs per shard is probably a really good starting point.
Thank you. Regarding the 23 to 25% decrease in performance on HDFS, what metrics were being measured? Query latency, indexing, etc.
Sure. Yeah, so that was straight indexing on the same exact hardware. So I took the same data set, the same indexers, client application, which was MapReduce itself, and basically Solr, I had two collections. One, and I didn't index them concurrently, right? So one basically used the local file system, and the other used HDFS using the same file system. So it was all the same hardware. It was just basically routing the docs through HDFS. So again, as I mentioned, there are probably, that's straight out of the box off the wiki config for HDFS directory factory. So there are probably tunables that you can go in and tune that, but maybe that gets you down to only a 15% hit. I think the key here is that there is some slowdown, and that's, my test was strictly indexing on the read and query side. So there is the block cache, which behaves a lot like the OS file system cache, and so that's going to help with read performance if you have enough memory, and that's the same problem there. So queries and read performance is a little bit harder to measure because of that memory thing, but I suspect it'll be a little less, but maybe not quite the same hit as indexing because of the utilization of that block cache.
Great. The next question is it right to think that having Solr index and documents on HDFS lends the only advantage of using the HDFS replication mechanism? If not, what are the other benefits of Solr on HDFS?
Sure. So I think a lot of the benefits, as I mentioned, are sort of operational efficiency, governance, security, those type of things that the IT organization cares about deeply. The other one, and I think it's, and I may not have made it this as clear as I should have, is the auto add replicas feature. That can kind of serve as a way to not use Solr replication and just rely on HDFS replication. And then the other one that I think is interesting, and this is why I mentioned it, it's not in Solr yet, but it's being planned and details are being worked out, is the idea of you have one set of files in HDFS, and of course those are replicated using HDFS replication. And then you have multiple Solr replicas, right? In Solr speak, cores reading. So you have one writer, right, the leader, but then you can have many replicas reading from the same file set. Now that's tricky to do, and people have tried to do that in the Lucene world for a long time with network file systems and that, and it always failed. But with this HDFS stuff, I think it actually stands a chance to actually really work. And the deal there, I think, is that it will enable you to effectively really scale up how big your indexes are, because you can still have the replication that you need to prevent, like, outages and losing nodes and things like that. So it gives you the fault tolerance and the scalability on having more replicas serve queries. But what it doesn't do is pay the double replication cost that you have today. Now, I actually have talked to people doing this with other similar type stores like Azure Blob Store and things like that. So that's a pattern that's emerging, and I think it'll be interesting to keep an eye on that ticket. I don't remember the number, but it was in one of my slides that you can get. I think it was 6237, but don't quote me on that.
Okay, so the final question for today's session is going to be, how does Solr compare to Elasticsearch?
Okay, so a couple things, and I'll keep the comments really focused on sort of in this big data space. So I'd say first, both ecosystems and both sort of communities probably do a pretty good job at working in the Hadoop space, and I know that Elastic has a Spark connector, and as do we, and we at Lucidworks actually invest a lot in Spark and Solr integration. So I think those are all on par, all on parity. The more interesting comparison, I think, is actually looking at Fusion, which adds security and adds visualizations and analytics, and the ability to basically, do recommendations and pull signals in to impact relevancy and boosting, right? And then you have this very nice API as well as admin UI to basically manage your big data search solution. Plus, as I mentioned, all the connectors. So I think if you look at that comparison, then Solr Fusion is a very, very strong offering there. And so that's probably all I have to say about that. I think we're out of time as well.
Yep, thanks so much. And thank you everyone for joining us today. We are now out of time. Everyone who registered for this webinar will receive a link to the recording shortly, as well as the slides. And again, if we did not have time to answer your question here today, a member of the Lucidworks team will reach out to you. So thanks again for joining us, and we hope you have a good rest of your day.